Hello student, welcome to my channel Learn Physics. Today I will be discussing the JEE main paper of 24th January second half. Now this video will be extremely helpful to solve the numerical in the next entrance examination. Now let's start. Now, question number one. A cell of EMF 90 volt is connected across the series combination of two resistors, each of 100 ohm resistance. A voltmeter of 400 ohm is used to measure the potential difference across each resistor. The reading of the voltmeter is okay. Now, look at this combination. This is the 100 ohm resistance, this also the 100 ohm resistance, and look at this is the EMF of 90 volt applied across this. Now a voltmeter, look at this, of resistance, this is the resistance 400 ohm connected across the 100 ohm. Now what is the reading of voltmeter? Now voltmeter reading is equal to current into resistance of voltmeter circuit. What is the voltmeter circuit? Look at this. This is the voltmeter circuit. Now, the resistance of voltmeter circuit, this is the 400 ohm into 100 ohm divided by 400 plus 100. So, this is the 500. Now, this and this cancel out. So, this is the 80 ohm. Now, what is the current? Current is the, look at this 90 volt divided by 100 plus 80. So, look at this is the 90 divided by 180. So, this is the 0.5. Therefore, voltmeter reading, this is the I 0.5 into resistance of voltmeter circuit. So, this is the 80. Therefore, this is the 40 volt answer. Now, option A is correct. Okay. Now, look at this question number 2. The electric field and the magnetic field components of electromagnetic wave going through the vacuum is described by Ex. Look at this Ex, this is the electric field vector, By is the magnetic field vector. Then the correct relation between E naught and B naught. You know the velocity of EM wave is the ratio between E naught by B naught. And this ratio is equal to coefficient of T, that is the omega, divided by coefficient of Z, that is the K. So look at this. This is the E naught K equal to omega into B naught is the correct expression. So look at this. This is the answer. Okay. Question number 3. The given below are two statements, one labeled as assertion A and other labeled as reason R. Look at this. A pendulum clock, when taken to Mount Everest, it becomes fast. Now, at the Mount Everest, G less than the G at the plane. So, T proportionate 1 by root under G. Therefore, T increases. As T increases, so the clock slows down. Okay. So, this option is incorrect statement. Now, reason R. The value of G is less in Mount Everest than the value at the surface of Earth. Okay, okay, this is the correct statement. So look at this, assertion false, reason correct. So look at this, option 2, A is not correct, but R is correct. Okay, understood? Next. Now question number 4. A long solenoid is formed by winding 70 turns per centimeter. If 2 ampere current flows, then the magnetic field produced inside the solenoid. You know the magnetic field inside the solenoid B equal to, look at this, this is the mu naught Ni. What is mu naught? Mu naught is the, look at this, 4 pi into 10 to the power minus 7. Okay. Now what is N? Look at this, N is the 70 turns per centimeter it should be converted into turn per meter. So this is the 70 into 100 is the turn per meter, and I is the 2 ampere. Now look at this. This is the 4 into 22 by 7 into, look at this. This is the 10 to the power minus 4 into 7 into 2. Now this and this cancel out. So look at this, 8 into 22 into 10 to the power minus 4. Look at this, 8 into 22, this is the 176. So this option is correct. Okay, next. Now question number 5. A body of mass 200 gram is tied to a spring of spring constant 12.5 Newton per meter, while the other end of the spring fixed at O. If the body moves about O in a circular path on a smooth horizontal surface with constant angular speed 5 radian per second, then ratio of the extension of the spring to natural length. Look at this. Suppose this is the circular path described by the spring. Okay. So look at this. This is the spring. Okay. Here mass M experiences outward centrifugal force M omega square into X into R. R means the original length plus extension. Okay. Now here force is the K into X. Okay. So this force is equal to this force. Understood? Now look at this. K is the 12.5 into X. This equals to mass. Mass is the 200 gram, that is 0.2 kg. Omega is the 5 radian per second. So this is the omega square. So this is the 25, and this is the L plus X. Now 25 into 0.2, this is the 5. Now this 5 and 12.5. So this is the obviously 2.5. Therefore 2.5x, this equal to L plus X. Therefore, look at this. This is the 2.5x minus x equals to L. Therefore, x by L, this is the 1 by 1.5. Okay. So, this is the, look at this. This is the 2 by 3. Therefore, option C is correct. Okay. Now, look at this assertion reasoning type question. Now, look at this assertion is steel is used to construction of building and bridges. Steel is more elastic than steel is more elastic and its elastic limit is high. Okay, this is correct and this is also correct, and it is the correct explanation of A. So look at this, both A and R are correct, and R is the correct explanation of A. So option 2 is correct. Okay. Now look at this question number 7. A photon is emitted in transition from n equal to 4 to n equal to 1 level in hydrogen atom. The corresponding wavelength for this transition. Look at this. Here H is given. Now look at this. For transition of this, we know 1 by lambda. This equals to R into, this is the 1 by 1 square minus 1 by, this is the 4 square. Okay, understood? So look at this R. So here R into, this is the 1 minus, this is the 1 by 16. So look at this. This is the 15 by, this is the 16 R. Therefore, lambda is equal to 16 by 15 into 1 by R. Now you know 1 by R, this equals to 912 angstrom. That is, this is the 91.2 nanometer. Now look at this. So option is slightly greater than 91.2. Look at this. This option not correct, not correct. This is the correct option. Okay, understood? Next. Look at this. Question number 8. The velocity time graph of a body moving in a straight line shown in figure. Look at this. This is the constant velocity, 8 meter per second. This is the velocity minus 4 meter per second. This is the 4 meter per second. This is the minus 4 meter per second. The ratio of displacement to distance traveled by the body in 0 to 10 seconds. Look at this. Now this distance is the 8 into 2, so this is the 16. Now this distance, this is the minus 8. Now this distance, this is the 16, and this is the minus 8. So displacement is the, look at this, 16 plus 16 minus 8, and this is the minus 8. Okay, so this is the 16. No problem. Now distance 16, 16, 6, 8, 8. So this is the 48. So ratio is 16 by 48. So this is the 1 by 3. Okay. So look at this option. This option is correct. Question number 9. Let gamma 1 be the ratio of molar specific heat at constant pressure and molar specific heat at constant volume for monatomic gas, and gamma 2 for the diatomic gas. Now you know gamma 1, this is the 5 by 3. What is gamma 2? This is the 7 by 5. So ratio of gamma 1 divided by gamma 2. This is the 5 by 3 divided by, this is the 7 by 5. Okay. So this is the, look at this, this is the 25 by 21. Look at this, option B is correct. Okay. Look at this, if two vectors P vector equal to I cap plus 2mj cap plus mk cap and q vector equal to 4I cap minus 2j cap plus mk cap are perpendicular to each other, then the value of m. Now you know the condition of perpendicularity between p vector and q vector is p vector dot q vector equal to 0. So look at this here, p vector dot q vector, this equal to 0. Now coefficient of I 1, here coefficient of I 4. So this is the 1 into 4 plus this is the coefficient of m2, and this is the coefficient of, now this is the coefficient of j2. Now this is the coefficient of j is the 2m, and here is the minus 2. So this is the 2m into, this is the minus 2. And look at this, this is a coefficient of m and this is the coefficient of m. So this is the m square, this equal to 0. Okay, so look at this is the m square minus 4m plus m, this equal to 0. Okay, therefore this is the m minus 2 whole square. So what is the value of m? M is the 2. So look at this, this is the option 2 is correct. Okay, understood? Now JEE main question is very simple question. If you just practice the NCERT paper, you can easily solve all the numericals, and you get 100 percentile in physics. I have one short video for NCERT chapters. You can watch this video, and if you watch this video, you can solve all the numericals of JEE main. Okay, now look at this. Question number 11. The frequency nu of an oscillating liquid drop depends upon the radius of the drop, density rho of the liquid, and surface tension S. Okay, here nu equals to R to the power A, rho to the power B, and S to the power C, the value of ABC. Now look at this. Here dimension of nu is, this is the m naught, this is the n naught, T minus 1. Okay, look at this, L to the power A. Density ml minus 3, so to the power, this is the B, and S is the mt minus 2 to the power, this is the C. Okay, so therefore look at this, this is the m to the power, this is the B plus C. L to the power, look at this is the A minus 3B, and T to the power just minus 2C. So applying the principle of dimensional homogeneity, you can easily calculate ABC. Now power of m is equal to power of m. So look at this, B plus C equal to 0. Okay. Now power of L is equal to power of L. So this is the A minus, this is the 3B, this equal to 0. And power of T, look at this is the 2C, this equal to minus 1. So look at this, C equal to, this is the half. Now B plus half, this equal to 0, so B equal to minus half. Now A equal to, this is the 3B, therefore this is the 3 into minus half, so this is the minus 3 by 2. So look at this, A is the minus 3 by 2, B is the minus half, and C is the half. So look at this is the option 4 is correct. Okay. Now look at this question number 12. In an isothermal change, the change in pressure and volume of a gas can be represented for three different temperatures: T3 greater than T2 greater than T1. Now, first of all, discuss option 1. A line is drawn. This line represents the constant pressure P. Okay. Now, this represents the, look at this, this represents the volume V1. This replaces the volume V2 and this replaces the volume V3. From the graph, look at this here, V3 greater than V2 greater than, this is the V1. Okay. Therefore, look at this, PV3 greater than PV2 greater than PV1. So RT3 greater than RT2 greater than RT1. Okay. So this graph is the correct option. Okay. Now look at this question number 30. When a beam of white light is allowed to pass through a convex lens parallel to the principal axis, the different colors of light converge different points on the principal axis after refraction. This is called, this is the chromatic aberration. The red rays meet further away from the violet ray. Okay. Now question number 14. Look at this. There is a matching type question. Look at this AM broadcast. Here, look at this AM broadcast, FM broadcast, television satellite, and here frequency given. Look at this AM broadcast is done in least frequency. So look at this. This is the AM broadcast. So this is the A. Now FM broadcast is slightly higher than the AM broadcast. So look at this. This is the B. Okay. And satellite communication needs the largest frequency. So look at this. This is the D. So look at this, television is the, this is the C. Okay. So this is D. Now look at this, A to B1. Look at this, A to B1, C4, D4. Okay. So look at this option is correct. Okay. Now statement 1. The acceleration due to Earth's gravity decrease as you go up or down from the Earth's surface. Yes, it is correct statement. Now statement 2. The acceleration due to gravity is same at a height h and depth d from the Earth's surface. If h equal to d. No, 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 no. This is the incorrect statement. So statement 1 is correct and 2 is incorrect. So option B is correct. Okay. Now question number 16. The alpha particle, the proton and the electron have same kinetic energy. Which one have flowing the correct in case of their de Broglie wavelength? Look at this, the de Broglie wavelength in terms of kinetic energy. This is the lambda equals to h divided by root under 2 me. Okay. So look at this, lambda inversely proportional to 1 by, this is the root over m. No problem. Therefore, as mass of alpha particle greater than proton and mass of proton greater than electron, so de Broglie wavelength for electron is more than the de Broglie wavelength of proton more than de Broglie wavelength of alpha particle. So look at this, option C is correct. Okay. Now question number 7. Look at this. This is circuit. We have to identify which category of gate it is. Now look at this. A, this is the B, and this is the Y. Look at this. A off, B off, then bulb on. This is the one. A off, B on, bulb on. A on, B off, bulb on. A on, B on, then bulb is off because current flow in this direction. Therefore, look at this. This is the output of NAND gate. So look at this. Option 2 is correct. Okay. Now look at this question number 18. If the distance of the Earth from the Sun is 1.5 into 10 to the power 6 kilometer, then the distance of an imaginary planet from the Sun, if its period of revolution is 2.83 years. Now look at this here, T2 equals to 2.83. This is equal to 2 root 2. Okay. Now T1 for Earth, this is the 1 year. Okay. No problem. Now look at this here, R2 is the question mark and R1 is given. This is the 1.5 into 10 to the power 6 kilometer. Now from Kepler's third law, this is the T2 square by T1 square. This equal to, this is the R2 by R1 whole cube. Okay. Therefore, R2 by R1, this equals to, this is the T2 by T1 to the power, this is the 2 by 3. No problem. Now look at this. This is the T2 is the 2 root 2 by 1. So look at this. This is the root 2 cube to the power, this is the 2 by 3. This and this cancel out. So this is the 2. Therefore, R2 equal to, this is the 2R1. So look at this. This is the 2 into R1. Look at this. R1 is equal to 1.5 into 10 to the power 6. So look at this. This is the option 2 is correct. Okay. Now question number 19. Look at this, the electric potential at the center of two concentric half rings of radius R1 and R2 having linear charge density lambda. Okay, look at this. This is the very easy time numerical. First of all, you have to calculate the charge on the ring. Look at this charge on the inner ring. This is the pi into R1 into lambda. So potential at the center due to charge in the inner ring, this is the charge by 4 pi epsilon naught into R1. Okay, now pi, R1 cancel out. So this is the lambda by 4 epsilon. In the same way, look at this. The potential due to, this is the potential V1. Now potential due to outer ring, this is the charge pi into, this is the R2 into lambda divided by 4 pi epsilon naught into R. Okay. Now this cancel out, pi cancel out. Therefore, look at this. This is the lambda by 4 epsilon. Now total potential this plus this. Okay. This. So this is the lambda by 2 epsilon. Okay. So look at this option 4. So look at this option 4 is correct. Okay. Now look at this. This is the last question of MCQ. A metallic rod of length L is rotated with angular speed omega normal to the uniform magnetic field B about an axis passing through one end of the rod as shown in the figure. The induced EMF will be, look at this, if a rod is rotated about its one end with an angular velocity omega, then induced EMF, this is the half, this is the B into omega into L square, where L square is the length of the rod. Okay. So look at this. This is the option 2 is correct. Okay. Now 21. The energy released per fission of nucleus X240 is 200 mega electron volt. The energy released of 120 gram of pure this. Now number of mole, this is the 120 divided by 240. So number of atom, this into 6 into 10 to the power 23. No problem. So this is the 3 into 10 to the power 23. Now energy produced in efficient is 200 MV. So energy produced in this fission reaction, so this into this. So this is the 6 into 10 25. Okay. Now question number 22. The three identical resistors with resistance R equal to 12 ohm and two identical inductors with self-inductance 5 Henry are connected to an ideal battery of EMF 12 volt as shown in the figure. Look at this. This is the 12 volt battery. Okay, these are the resistors. These are the resistors. Okay, and two inductor. Okay, the current through the battery after long the current through the battery long after the switch has been closed. After long time, the inductor offers zero resistance. So it will be a perfect conductor. Therefore, three resistors are in parallel combination. So equivalent resistance, look at this. This is the R by 3. Now R by 3 means this is the 12 by 3. So this is the 4 ohm. Therefore, current through the battery, this is the 12 volt divided by 4. So this is the 3 ampere. Okay. Look at this. A parallel plate capacitor with air between the plate has a capacitance of 15 picofarad. Therefore, 15 picofarad, this equal to, this is the epsilon naught A divided by D. Okay, no problem. Now, the separation between the plate becomes twice and space between them is filled with a dielectric medium or dielectric constant. This is the 3.5. The capacitance becomes X by 5 picofarad, the value of X. Look at this. This is the X by 4. So this is the K, this is the 3.5 into epsilon naught A divided by, this is the 2D. Okay. Now this ratio, this is the 15 picofarad. So look at this. This is the 3.5 into 15 divided by 2. Okay. So look at this. X equals to, this is the 4 into, this is the 3.5 into 15 divided by 2. Okay. Now look at this. This is the 7 into 2, 14. So look at now, this is the 2. Now this is the 2 and 4. This is the 2. Now 2 and 3.5, 7 and 7 into 15. This is the 105. Okay. If a copper wire is stretched to increase the length by 20%, the percentage increase in resistance of the wire. Look at this. For stretching, resistance R is directly proportional to length of the conductor. Okay, directly proportional to the square of the length of the conductor. So look at this. This is the R2 by R1. Okay, this equals to, this is the L2 by L1. Okay, whole square. Now 20% increment, this means L2 by L1. This is the 120 divided by 100. Okay, this square. So look at this. This is the 1.44. Therefore, if you express in percentage, so this is the 1.44 into 100%. So this is the 144%. Okay, no problem. Therefore, increment of resistance, this is the 44%. A uniform solid cylinder with radius r and length L has moment of inertia I1 about the axis of the cylinder. A concentric solid cylinder of radius r dash equals to r by 2 and length L dash equals to L by 2 is carved out of the original cylinder. I2 be the moment of inertia of the carved out portion of the cylinder, then I1 by I2. Now look at this. I1 is this is the half, this is the mass into this is the R square. No problem. Now, when radius of the cylinder, when the radius of the carved out cylinder be R by 2, so its mass becomes 1/4. Its length becomes L by 2, so mass becomes 1 by 8. So look at this, this is the I1, so I2 become, look at this is the half into this is the M by 8 divided by this is the R by 2 whole square. Okay. So look at this is the I1 divided by 32. So look at this, I1 by I2 is obviously 32. Now question number 26. A mass M is attached to the free end of a spring executing SHM with period 1 second. If the mass is increased by 3 kg, okay, this is the 3 kg. The period of oscillation increases by 1 second, the value of mass M. Now look at this time period 1, this equals to 2 pi root under of this is the M by K. No problem. Now time period is when 3 kg mass is added with it, that time period increased by 1 second. So this is the 2 into this is the 2 pi root over M plus 3 divided by K. Okay. No problem. Therefore, 2 by 1, this equal to root over of M plus 3 by M. So look at this, squaring this is the 4. So 4 by 1, this equals to M plus 3 by M. What is the value of M? Obviously, M equal to 1. So this is the 1 kg. Okay. Now question number 27. A body of mass 1 kg begins to move under the action of a time-dependent force F equals to T I k plus 3 T square J k Newton. We have to calculate power developed in T equal to 2 seconds. Now, first of all, we have to calculate velocity at T equal to 2 seconds. Now look at this. Here, acceleration A equal to, this is the force by mass. Mass equals to 1 kg. So acceleration is equal to, this is the Ti plus this is the 3t square. This is the J cap. Now acceleration A equal to dv by dt. So look at this is the dv equal to, this is the I into T dt integration, and this is the 3j, this is the t square dt. Okay, this is the 0 to 2, and this also 0 to 2, and this is the 0 to v. Okay, so look at this is the t square by 2. So this is the I by 2 into 2 square. Okay, plus look at this is the 3j by 3 into 2 cube. So this is the 2 cube. So look at this is the 2I cap plus, look at this, 3 cancel out. So this is the 8j cap is the velocity. Now what is the force after 2 seconds? Look at this is the 2I cap plus 12j cap. Okay, this is the force, this is the velocity. So power is the dot product of, this is the force vector dot velocity vector. Okay, so look at this, what is the force vector? Now force vector is the 2I cap plus 12j cap. And what is the velocity vector? Look at this, velocity vector is the 2I cap plus 8j cap. Okay, no problem. Now 2 into 2, this is the 4. 12 into 8, 96. Now 4 plus 96. So this is the 100. So power is equal to 100 watt. Therefore, this is the, now question number 28. A single turn current loop in the shape of a right angle triangle of side 5 centimeter, 12 centimeter, and 13 centimeter is carrying a current of 2 ampere. The loop is in the uniform magnetic field of magnitude 0.75 Tesla, whose direction is parallel to the current in the 3 centimeter side of the loop. The magnitude of the magnetic force on 5 centimeter side. Look at this. This is the 5 centimeter, this is the 12 centimeter, and this is the 13 centimeter. Okay, look at this. The direction of current along this direction. Okay, no problem. So look at this. The angle between the current and length 5 centimeter. This is the theta. So force F equals to, look at this. This is the B. This is the I into L into sin. No problem. Now what is B? Now what is B? B is the 0.75 Tesla. What is the I? Look at this. I is the 2 ampere. What is the length? Length is the 5 by 100 meter. And sin theta, this is the 12 by 30. So this is the 12 by 30. No problem. Now look at this. This is the 10. So this and this cancel out. 12. So look at this. This is the 9 by 130. Okay. Now this is the 9 answer. Now question number 29. A spherical ball of radius 1 millimeter and density 10.5 gram per cc is dropped in glycerin of coefficient of viscosity this. Density 1.5 gram per cc. The viscous force on the ball when attains a constant velocity is this. The value of x. Now viscous force is equal to apparent weight. Now what is the apparent weight? Apparent weight is the 4/3 pi. This is the r cube into rho minus sigma into c. Okay. Now look at this. This is the 4 by 3 into pi. This is the 22 by 7. This is the r cube. Look at this. Radius 1 millimeter. So 10 to the power minus 3 whole cube. So this is the 10 to the power minus 9. Now rho means 10.5 gram per cc. It should be converted into 1000. And this should be multiplied by, this is the 1000. Therefore, look at this. This is the 10500 minus 1500 into, this is the 9.8. Now look at this. This is the 7 and 9.8. So this is the 1.4. Now look at this. This is the 4 by 3 into 22 into 10 to the power minus 9 into, this is the 9000, okay, into 1 point. Now this and this cancel out. So this is the 3000. Okay. Now look at this. This is the 14 into 3. So 42. This is the 42 into 4 into 22. This into 10 to the power minus 7. So look at this. Multiplication of this factor is equal to this. So look at this. We get x to the power minus 7. Here minus 6. So look at this. This is the 7th answer. Now question number 30. A convex lens of refractive index 1.5, focal length 18 centimeter in air is immersed in water. The change in focal length of the lens. You know, when a lens is immersed in water, its focal length becomes 4 times. Now, focal length of this is the 18 centimeter. So, focal length becomes 72 centimeter. Therefore, change of focal length, this is the 72 minus 18. So, this is the 54 centimeter. Okay. Many thanks for watching this video. This video will be extremely helpful for your NEET and JEE main examination. Okay.